Hey everybody, Mr. Judson here. So let's see, last week we talked about partial fractions, and so we're just going to push those ideas a little bit farther. And so we'll go ahead and solve this integral. But one of the things that you want to make sure you catch right from the beginning is if the exponent numerator is greater than or equal to the exponent denominator, we need to start off with long division. Okay? So let's go ahead and do that first and then see if we can solve this using partial fractions. You guys go ahead and try it. Alright, so I'll do my long division up here. I've got x squared minus x divided by x squared plus x plus 1. So x squared would go into here one time. When I multiply back, I would get x squared plus x plus 1. And then I would go ahead and subtract all that. So that minus this is going to be 0. Here I would get a negative 2x, and 0 minus 1, we get that right there. So my new integral becomes the integral from 0 to 1 of, let's see, this is going to be 1, and what I'm going to do is I'm going to subtract a negative sign out of each of those. So I've got 2x plus 1 over what I'm dividing by, x squared plus x plus 1. And so there's 1 minus 2x plus 1 over x squared plus x plus 1 dx. And so the integral of this is just going to be x. Over here, if I take the derivative of this, remember, every time you see a fraction, you want to think u prime over u first. So derivative of this would be 2x plus 1, which is exactly what I have. So minus natural log absolute value of x squared plus x plus 1. And we're evaluating that from 0 to 1. So I guess this problem really has nothing to do with partial fractions. It shows up in that chapter, but again, they're just making sure we don't forget what we've already learned. Alright, so I plug in a 1, I get 1 minus the natural log of 1 plus 1 plus 1. That's 3. Minus what you get when you plug in a 0, which would be 0 minus natural log of 0, 0, and 1. So natural log of 1. And the natural log of 1 is 0. So really that's my answer right there. 1 minus natural log 3, which is about equal to, if I do that on my calculator, 1 minus natural log 3, I get a negative 0.099. There's my answer for that one. Hey, by the way, just a quick reminder. So this week, Thursday at 10 o'clock, I'll be set up at Wilson High School out in front of the main office. I'll have a table there. You guys can pull up. You have to remember, if you're taking the Central Washington final, you have to check in your T-89 and check out a T-84. You cannot take the Central Washington final until I get your T-89 back. Okay? So even saying to me, Judson, I have a T-84 at home, I'm just going to use that. No, it's not okay. I have to be guaranteed that you do not have a T-89 in your possession. And so they all need to be checked in. Okay? All right, those who are not taking the Central Washington final, you can check in your T-89 at that point as well. We really only have one last lesson, which is tomorrow. But if you're not taking the final, it's really not an issue. You can bring your calculator and book and turn those in. So I will be in front of the Wilson office between 10 o'clock and 11 o'clock. Make sure when you come, you got your mask and you got your gloves and stuff on, so that we're being safe. That really has to happen, you guys. You know, if you're not, you know, mask and gloves, I can't even touch your stuff. So anyway, we need to do that just so that we're being safe. Okay. All right. Let's do another one. All right. So again, it looks a little more difficult. This time, I think to be able to factor this denominator, we're probably going to have to use synthetic division. All right. So you guys go ahead and try that. So let's see, if I'm going to factor this, I'm going to go 1, -1, 1, and 3. And I'm going to do synthetic division. So what I'm going to do is I'm going to try numbers that divide into 3 evenly. 1 only works if all of these add up to 0. So I'm not going to try that. Let's try -1. So bring the first number down. Multiply, you get -1. Add that to this, you get -2. If I multiply here, I get a +2. Add that to 1, I get 3. And then -3 plus 3, that's 0. So there's one of my factors, x plus 1. Opposite of what we see there. This is going to be x squared minus 2x plus 3. So if I factor that, I've got x times x. This will have to be a -3 times a +1. So what I have here is x squared minus 4x plus 7 over x minus 3 times x plus 1 squared. And so that means that my fractions are going to be a over x minus 3 plus b over x plus 1 plus c over x plus 1 squared. And so now what I need to do is I need to multiply this whole thing times the least common denominator, which is this right here. So when I do that, all of this will cancel on this side, so I get x squared minus 4x plus 7. If I write all this stuff down here next to a, the x minus 3's will cancel, and what I'll be left with is x plus 1 squared. If I write all this stuff next to b, I'm going to be left with b, let's see, an x plus 1 will cancel, but I'll still have one of those left with an x minus 3. So x minus 3 times x plus 1. And then for c, the x plus 1 squares will cancel, and I'll have just this x minus 3 left. So remember, if that's a little too much, if I'm skipping too much for you guys, take the time to write down this least common denominator here, 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 and here, and work that whole thing out. You know, we don't want to make a simple mistake along the way. All right, so now I'm going to let x equal some numbers. So if x equals -1, then what I get is 1 plus 4, that's 5, plus 7, that's 12. That'll be a -1 plus 1 is 0, so that's gone. Get another 0 here, that's gone. Put a -1 here, I get a -4c. So divide by a -4 and I get c must equal -3. So there's my first numerator for this fraction. Now I'm going to let x equal 3. So if x equals 3, then what I get is 9 minus 12, that'll be a -3, plus 7, that's 4. Here I'm going to get, if I put a 3 in there, I get 4 squared. That's 16, so I'm going to get 16a. And then if I put a 3 in, that'll be 0 times everything, that's gone. This will be 0, that times c, that'll be gone. So right here we have a equals when I divide by 16, I get 4 over 16, which is 1/4. There's my second value. And so now to get b, I just need to pick some other number. So if x equals, I'm going to choose 0 because that's an easy number. I'm plugging everything in right here. So if I plug in a 0, I get 0, 0, and then 7 equals, this will be 1 squared, which is 1, times a, which is 1/4. For this right here, I get -3 times 1, that's -3 times b. And if I put in a 0 here, I get a -3 times c. Since c is a -3, that's a -3 times a -3, that's 9. Alright, so to solve this, I'm going to move the -3b over to this side so that it becomes positive, and I'll move the 7 over here. So when I subtract that, 9 minus 7, that's going to be 2. Plus a 4th, I get 2.25, and I'll divide that by 3. So b is going to equal, I'm going to do this the easy way, I'm just going to go 2.25 divided by 3. I got 0.75. If I convert that to a fraction, it'll be 3/4. So 3/4. Alright, so this is now the integral of, so here's my first fraction. I've got a over x minus 3. A was 1/4. I'm going to move that 1/4 to the outside, so I have 1 over x minus 3 dx. My second integral, so my b value is 3/4, so I'm going to move that to the outside and have 1 over x plus 1 dx. I'm going to need a little space here. And so now my last integral, c was a -3, so I'm going to move that to the outside. And what I'm left with is 1 over x plus 1 squared dx. Alright, so let me get rid of all this extra stuff here. It's a lot of work just to get this down to, something that's easy to solve. But, once we get here, it's not too bad. This is u prime over u, so I've got 1/4 natural log absolute value of x minus 3. This is also u prime over u, so plus 3/4 natural log absolute value of x plus 1. And here I've got something inside parentheses raised to an exponent, and to me that sounds like substitution. So if I let u equal x plus 1, du is going to equal 1, and I just took the derivative of x, which I have that here. So this is going to become a -3 times the integral of u to the -2 du. So add 1 to the exponent, you get -3u to the -1. Divide by the new exponent, plus c. And so my final answer here is 1/4 natural log absolute value of x minus 3 plus 3/4 natural log absolute value of x plus 1. Negative divided by negative is a positive. That u needs to drop down below the fraction bar, so it's going to be 3 over x plus 1 plus c. And I'm not going to combine these two just because if I move the 1/4 and the 3/4 up so that I have fractional exponents, it just gets a little messy. So I'll just stop right here and leave it like this. All right, so this one required synthetic division to factor this, and then it was, a little bit of work setting up each of those integrals or fractions. All right, let's try one more. All right, you guys go ahead and try this one. In the denominator here, I've got x to the fourth plus 6x squared plus 9. All right, so I think if I factor this, this could be x squared, this could be x squared, and then plus 3 and plus 3. So that works. So that means that, I'm just going to write it right here and I'll go back and erase it. So I've got x squared plus x plus 3 over x squared plus 3 squared. And that's going to equal, I'll have one fraction. Now, since this is a quadratic, my numerators have to be linear, which means I need ax plus b over x squared plus 3 plus cx plus d over x squared plus 3 squared. You can see how these are getting a little more complicated. All right, so I want to multiply through by the least common denominator, which is this. So that means here that'll cancel, here it'll cancel. And for this one, I'll still have one x squared plus 3 left in the numerator. So my new fraction looks like this, or my new equation. X squared plus x plus 3 is equal to ax plus b, make sure that's in parentheses, times, I would have had two of those factors here. One would cancel, so there's still an x squared plus 3 left. And then plus cx plus d. And so there's nothing here that would make this equal 0. So I'm left just plugging random numbers in right from the start. So I might as well start with the easiest number. If x equals 0, I'll get zeros and then 3 equals, plug in a 0 here, you get just b. Plug in a 0 here, you get 3, so 3b. Plus, plug in a 0 there, you get 0 plus d. So that didn't really help me solve anything. It just gave me an equation with b's and d's in it. All right, let's try another one. Let's let x equal 1. Pick the next easiest number. So I get 1 plus 3, that's 5. And that equals, I'm going to get 4 right here, and I have to distribute that. This will be 1, so 4 times 1, I get 4a. 4 times this, that'll be 4b. Plug in a 1 there, you get just plus c plus d. Didn't really help me out. So, one of the things when you talk about solving a system of equations, however many variables you have, that's how many equations you need. So I'm going to need at least 4 equations here. This is going to get a little nasty. So I need to pick one more number. Let's try -1. So x equals -1. Plug that in, I get a +1. -1, that's 0, plus 3. If I plug in a -1 here and square it, I get 1, plus 3, that's 4. This will be a -1 times a, so 4 times a -1, I get a -4a. If I take 4 times b, I get plus 4b. This will be a -1, so I'll get a -c, and then plus d. Now, you guys may not see this, but something good just happened. If you think back to solving systems of equations, you know, our method of solving a system of equations, let me just kind of highlight these two, is, and normally we would do this with x's and y's if we're solving a system of equations. But what we like to see is we like to see things opposite, because when you add those together, you get 0. Same thing here. So if I add these two equations together, I get 8 equals, that's 0. This will be 8b, that's 0, and then plus 2d. I could then take this and divide everything by 2 just to make the number smaller. And so what I get is 4 equals 4b plus d. So now, if you look at our first equation, that has the variables b and d. This has the variables b and d. And so what I'm going to do is I'm going to take this one and write it right here. 4 equals 4b plus d. I'm going to take this one and I'm going to multiply everything on both sides by a -1. And I'm going to add those, or add that over here, so I get a -3 equals a -3b minus d. And when I add those, I get 1 equals b, and that's 0. Aha! Just figured something out. Alright, so now I could take that 1 and plug it back into either one of these. Let's plug it in right here. If b is 1, that's 4. Move the 4 over here and subtract it, you get d equals 0. So that's kind of nice. So here's what I need to know. A equals something, b equals something. We just figured, oh, b equals 1. I got to figure out what c is equal to, and I just figured out that d is equal to 0. So now let me backtrack to these two equations. And if I plug, let me think here for a minute. I'm going to need one more, because you know, no matter what I multiply this by, the c's will always cancel and the a's will always cancel, and that's what I'm trying to figure out next. So I'm going to need one more equation to work with. So I've got these results written down. Let me just go back and erase this. And let's say if x equals 2, that's the next easiest number. So that would be 4 plus 2, that's 6, plus 3, that's 9, equals, if I put a 2 in here, I get 4 plus 3, that's 7. 7 times 2a, that would be 14a. 7 times b, and let's see, we've got a 2 here, so that's plus 2c, and plus d. But at this point, we know that d is 0, right? So I could do that for all three of those equations. And so what I want to do now is I want to take these two, I'll go ahead and plug in a 1 for b, and then I'm going to solve that system of equations. So if I put a 1 in here, that's 4. Move it over and subtract it, I get a -1 equals a -4a minus c. If I put in a 1 for b here, that's 7. Move it over and subtract. That's 2, so I get 2 equals 14a plus 2c. So now I'm going to solve this system of equations. And I can get these to be opposite by multiplying the top equation by 2. So let's do that. When I do that, I get -2 is equal to a -8a minus 2c. And so now I'm going to add the equation written here in black to the equation written in red down here, the third one, or second one. So when I add the negative 2 to positive 2, I get 0. Negative 8 plus, or negative 8a plus 14a is going to be 6a. And negative 2c plus 2c, that's going to be 0. So divide by 6, a equals 0. All right. So now to figure out what c is, I just need to plug that 0 back into either this equation or this one. Or any of them, for that matter. I think the easiest one is probably right here. So if I say negative 1 equals negative 4 times 0, that's 0, minus c, multiply both sides by a negative 1, you get c equals 1. All right, I now know what my fractions are, so let's see. C is 1. So here's the two fractions that I want to write down for my integral. So let me erase all this stuff so I've got some room to work here. And so I'm now trying to solve the integral. A was 0, b was 1, so that's 1 over x squared plus 3 dx, plus this fraction, c was 1, d was 0, so that's the integral of x over x squared plus 3 dx. All right. Wow. So this one right here, to me, it doesn't look like a u prime over u. There's no parentheses raised to an exponent. I'm thinking arctangent right here. If I let u equal x, and my a value is going to be square root of 3, I do have u prime in the numerator, and so this should be 1 over a, which is 1 over the square root of 3, times arc tangent of u over a, x over root 3, plus, this integral does look like a u prime over u. If I multiply by 2 and do a 1/2 out here, so u prime over u, that means this is going to be 1/2 natural log absolute value of x squared plus 3 plus c. So the integration part, that was the easy part on this problem. It was trying to get this thing broken down into its two fractions that was a lot of work. All right, I gotta know. Does this work on the graphing calculator? Can our graphing calculator do partial fractions along with inverse trig functions and u prime over u? All right, so I've got the integral of, in parentheses, I've got x squared plus x plus 3 divided by, in parentheses, x raised to the 4th plus 6x squared plus 9 with respect to x. And my calculator got, so let's see, they changed this to root 3 over 3, so they rationalized that. Arctangent, they've got root 3 over 3 times x, so yeah, they rationalized this. Minus, they've got 1 over 2 times x squared plus 3. There's no natural log in there. And I just erased my work, so I can't go back and check that. Oh, I hope you guys saw this. That should have been squared, right? So now that becomes substitution. Way to go, Judson. All right, so let me just back up and redo this piece. So let's see, I would have had u equals x squared plus 3. So du would be 2x dx, so I still needed that 2. And so now this integral would be 1/2 times the integral of u to the negative 2 du, which would equal 1/2 u to the negative 1 over negative 1, which means this right here, positive divided by a negative. When I drop this down below, I've got 2u in the denominator. I've got a 1 in the numerator, and so I've got 2 times x squared plus 3, which is what the calculator had, so clearly that calculator is a lot smarter than I am. Hopefully when I forgot that too, you guys were all screaming and yelling, but yeah, I couldn't hear because, yeah. There it is, that's what our calculator had. Get you guys an assignment. All right, so we're on C18. Page 559, we're going to do 25, 27, 31. This is shorter because obviously these are long problems. They take a little bit of time to get through, and so we don't want to do a whole bunch of those. All right, so tomorrow on Thursday, I'll see you guys at 10 o'clock at Wilson in front of the office to check in calculators and books for those who want to. If you want to hang on to your book for now, that's fine. There's a check collection process in the works. I don't know what it is yet because no one's told me. All I know is they're working on it. But if you want to check stuff in tomorrow because you have a PDF version of the book, then that's fine. That's at 10 o'clock, and then tomorrow we'll have our last lesson, and then we'll start reviewing for our Central Washington final. All right, you guys have a good day. Take care. Be safe.